We know a lot of stuff about the world. You know a lot of stuff about your world. If you're tired, you have a hard time learning. If you eat some food, you feel better and you can learn more, or you can exercise better. Things like that. In the natural world, we know that if you're a peacock and you've got bigger, brighter tail feathers, you're more attractive to mates of the opposite sex and you're going to have more offspring. We know these things, but how do we know them? How do we know what is true about the natural world? How do we know what to believe? The way we do this is called scientific thinking. And it's just a process. It's a way of looking at the world that helps us to understand what is true about it, what is not true, what is going to be helpful. And the way we do it, it's not really a linear method. It's just a way of thinking, but it's helpful to see that there typically are some common steps. The first thing, we make observations. We're humans. We can't help that. You walk around, you see things, and then you start to think, all right, I saw that. I think that means this. I think this is what's going on. And those are called hypotheses. They are our proposed explanation for what we see. And oftentimes outside of science, people will say, oh, I have a theory about this. And in science, we like to say if it's just your proposed explanation for something, it's a hypothesis. So you form this hypothesis, and a real strength of science is that we then say, all right, let's make a prediction. If it's true, then that means under these conditions, we should see this. Under these conditions, we should see this. And then we go one step further. We say, all right, well, let's collect the observations. Let's collect those conditions and see what happens. So, you can call them experiments, but they're not always in the lab. They're not always done by people in lab coats. They're just a way of making the observations. Then, based on what we see, we draw conclusions, we modify our hypotheses, or we get rid of them if they're wrong. And that's how we come to understand the world. So overall, the thing that's useful about scientific thinking is that it's organized. It's empirical, meaning that it's based on what we observe, and you're methodical about it so that you can kind of twist it around. You can say it allows us to get rid of ideas that are not supported by our observations. So we can throw out ideas that just are not helpful. And what it does is progressively leaves us with a more and more accurate understanding of what's going on in the world. Now, let me talk about one of my idiosyncrasies. I hate rain. I really hate rain. Snow, you can brush it off. You go inside, you're fine. Hot weather, I like. Rain, it gets on you, you're wet. You go inside, you're still wet, so on. It drives me crazy. And for a long time, I lived in an area where it rained a lot. But I was always making plans. I'm going to do this on the weekend. This weekend, I'm going to go kayaking. I'm going to go hiking, something like that. And I'd work all week, and then the weekend would come and it would rain. And I started to feel like somehow I was cursed. It's always raining on Saturday. All week long it didn't rain. Now it's raining on Saturday. And I formed this weird idea. And you could say, from what I was saying earlier, you could say, oh, I've made some observations. I have a hypothesis. I think it's raining more on Saturdays. And you could formulate a hypothesis. Does it rain more on weekends? Does it rain more on Saturday than it does on Monday? I could just mope around and think, oh yeah, poor me. That's what I think is going on. Or I could figure out if it's true or not. Now, your first thought probably on an idea like this, an observation, is it's ridiculous, right? How does the weather know what day it is? There was weather long before there were humans, right? It's a human construct. So clearly the weather can't know what day it is. Seems reasonable, but we can still figure it out. How would you figure it out? Just hypothetically. I like to do that just as a mental exercise. I want to know, does it rain more on Saturday than Monday? How would I do that? How would I figure it out? And this is at the core of scientific thinking, asking yourself, how would I figure this out? What would I have to do? In this case, we could solve it. We could say, all right, well, if I want to figure it out, I'm going to start with a spreadsheet. And I'm going to put each column, I'm going to put Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Then I'm going to say, all right, here's week 1, here's week 2, here's week 3, for as long as I want to do it. And every day, if it rains, I put how much it rains. If it doesn't, I put a 0. And I do that. Then I go to the next week, and I go to the next week, and so on. And I'd go all the way down. Then I'd figure out the average, right? Each column, you can figure out an average. And I'd say, all right, what's the average on Monday of rain? What's the average on Wednesday? What's the average on Saturday? Now I just have to compare those numbers. And if the weather doesn't know what day it is, they should be the same, right? It should just be evenly distributed. But we could do this. I was really excited when I discovered that I wasn't the only person who thought this was true. And there were researchers who said, hey, we think this is going on. So they looked at data from 17 years. And they said, hey, we can plot these data out. We can use a spreadsheet, but then we can turn it into a graph. And they did that, a graph. They did this. And look at, they plotted it, and you look at it, and the average rainfall on Mondays, 21 inches. The average rainfall on Saturdays, 26 inches. So based on this, you see this gradual increase, then it drops off on Monday, 22% more rain on Saturdays. I'm not kidding, I'm not joking. It's true. These are the data published in the journal Nature. They even ran an article saying, what's going on? Does it really rain more on weekends? And you might be tempted to think, wow, this scientific thinking really is ridiculous, because that can't be true. But they said, all right, is it true? If it was true, then we got to figure out, how is that? How could that be? And some researchers, not me, some other researchers had this idea. They said, hey, cars spew out particulate matter. And this particulate matter, they're very, very tiny particles. They hover in the atmosphere. They hang there. Moisture clings to them. The more particles are on the air, the more moisture you get. And this can build up until there's so much moisture in the air that you can't hold it there, and so it rains. When it rains, it takes all the particles out of the air, so now it's less likely to rain. So their idea was, they said, if it's coming from car exhaust, what do we know about how people drive? Well, we know that people drive a lot during the week, not as much on the weekend. So it builds up, and it just becomes increasingly likely, so that on Saturdays it's more likely to rain. Good idea. It's just a hypothesis. Good idea, though, right? How could we test it? How could we see if it was true? This is where there's a huge amount of creativity in science. People sometimes think that all the creativity is in the humanities or social sciences. Not true. What if we say, where did they collect the data? Where were they looking? Turns out they were looking, just coincidentally, they didn't occur to them, they measured rainfall for these 17 years along the east coast of the US. Huge highways there, tons of driving. They said, what if we were to look elsewhere? And there are satellites that can measure rain. They said, what if we look in the open ocean? What if we look in the middle of Australia, places where there are no cars? Then we make the same spreadsheet, Monday, Tuesday, Wednesday, Thursday, and so on. How much rain? We total it. They looked at 40 plus years of data in the open ocean. And when they calculated the average for each day, what do you think it was for Monday and Saturday? It's exactly the same. There's no difference in how much rain there is when humans aren't around driving our cars. So now you've got this situation where 2 minutes ago I said, I think it rains more on Saturdays. And you think, that's ridiculous. Weather doesn't know what day it is. And now you're thinking, well, yeah, the particulate matter, and it increases, and that causes the rain. And we know that's true because in the places without cars, there's no difference. In 2 minutes, 3 minutes, scientific thinking can change what you think about the world. And that's rare. Most people never change their mind about anything. It's hard to know. And here, bam, it's become completely obvious. Well, yeah, that's why it rains more on Saturdays. It's an interesting topic, but my focus here is on the process, scientific thinking. And we can apply it to other things. And they don't have to be science-y kinds of things. They can be anything where you want to understand better how the world works. So it tells us when we should change our mind. Now we just have to decide, what do we want to know about? What do we want to be more certain about what we think? Here's one. People rely on their senses. It's a big part of scientific thinking. We kind of imagine that whatever we see is true. We believe that it's true. Seeing is believing. That's why you have that quote. Now let's take that idea, though, and direct it towards an issue that is real relevant in our world. When crimes are committed, very frequently, probably in the majority of cases, the reason a person is convicted is because of eyewitness testimony. Someone says, I was there, I saw it, he did it. In court, when someone does that, that's considered pretty unassailable. That's powerful. If someone says he did it, he's likely going to jail. Or alternatively, someone says, I was there. He didn't do it. It wasn't him. They go free. So that causes me to have the question, all right, well, is eyewitness testimony perfect? If someone says, I was there, I saw it, then do we just believe it? Is that how it goes? And like the rainy days and Mondays question, we could figure it out. We don't have to just say, I wonder if. I don't think it is. It's not a matter of opinion. Either it's true or it's not true. When people are looking at a lineup and they say, I saw that person, do we know with certainty that they are accurate? So some researchers had a clever idea. They said, all right, we want to figure out how good eyewitness testimony is. Is it perfect? And they said, the way we can figure this out is like this. We're going to stage some crimes so that we know who did it. So it would be like right here. We could have somebody run through, punch me, grab a computer, and run out. And a whole class is sitting there, eyewitnesses. But the one difference to most crimes is that now in this case, we can test our hypothesis about eyewitness testimony being infallible. We can make a prediction that everybody's going to know who it is, and we'll know if they're right or wrong because we know who did it, because we staged the crime. So that's our experiment. See what I mean? That we call it an experiment, but it doesn't really resemble maybe the stereotypical experiment. So we do this, and the researchers who did this, they had the idea, they say, well, let's present the potential perpetrators in two different ways. In one case, we'll set them up like a traditional lineup. 5 people standing next to each other behind glass where they can't see you, and the person will say, that's the person, or that's the person, or they're not there. Sometimes they don't put them there. Alternatively, we can show a bunch of photos and say, tell us when you get to the one that did it. If eyewitness testimony is infallible, if it's perfect, shouldn't matter how you do it. They're going to see the person, then they got them. So they did this study, and they did it repeatedly, and they had lots of witnesses over and over. And what did they find? So our expectation would be, how often did they get the wrong ID? It would be 0%. And it would also be the same for the two methods. They did it, what they find? Bam. More than 30% of the time in a standard lineup, people got it wrong. They thought they knew, but we knew they were wrong because they were because we knew who did the crime. When they did it sequentially, significantly better. But about 10% of the time, people got it wrong still. So now we can conclude some things from that. We can say, hey, eyewitness testimony, not infallible. You have to give up that belief if you had that before. We see it. It's true. That's how the world is, whether you like it or not. That's what scientific thinking tells you. It says you can't believe that. It also tells you here that there's a difference. You're going to be a little bit more accurate if you look at them sequentially than if you look at the lineup. This has profound implications for the legal system. But I think it has more profound implications for how we view the world, how we figure out what should we believe, when should we change our mind, what's true, what do we know, how much confidence do we have. This method of approaching the world, making observations, proposing a hypothesis, making a prediction, then testing it somehow with your observations and looking at what you get to conclude and modify your hypotheses, that is an efficient pathway to understanding the world. I would say possibly the most effective and efficient way of understanding the natural world. Think about some other issues, other questions about the world that you'd like to know. If you take a vitamin supplement every day, does it reduce the likelihood that you get sick? Or if you get sick, does it reduce the duration of the illness? Or another question, do cell phones cause brain tumors, holding up the source of electromagnetic radiation to the side of your head? Or does increasing the amount of protein you consume when you are lifting weights a lot cause you to get more muscular? There are an infinite number of questions about the natural world. You should be thinking all the time, how could we figure that out? How would I decide if that's true or not? And that's how you develop your ability to use scientific thinking. And you'll find that it's super effective.